So we had to do the same thing on the t-square chart. Right? We had to do the same thing sometimes.
I just wasn't there yet because it's conservative data is too random. I don't know why. And then the one you just plug it in.
Yeah, but what I do, well, no, it would be the same thing if you put square of there, it makes sense. Yeah, so it says one step is squaring it, like we squared it above, so we're not squaring it. Yeah, exactly. If you put it down, exactly. So you don't really need it.
That's why I wish I would have just wrote the standard deviation.
You don't want to square it twice.
Sigma that we found, or this,
You found it, yes.
in the calculator, it said that's what it was.
So remember, the calculator doesn't know if it's a population. We know it's a sampler, so you can't use this one for anything. So use that square.
Say one twice.
This one comes from the plane.
Got you, Jeff. We got you.
My chi-squared doesn't. It's less than.
So it's in here. Just like the dishwasher. You failed.
Literally last night. My friends don't tell me you gotta watch.
White Chicks?
Yeah, they're telling me you gotta watch it for the longest time. It's been forever, and I watched it last night.
How'd you like it?
I actually really enjoyed it.
It's funny later on, like when you're older.
Some of the data.
I think it's funny, but some people think it's just
That was
stupid,
used
which it
in one of the forms.
Oh, it is, but it's super fun.
It's only one of these two. We know it's the
And then
same.
when I watched like half of me.
Square it.
I completed that. I was like, oh, I don't want to watch it. And I was like, oh, okay. It's not what I thought it was. It was actually pretty good.
Watch White Chicks, Mean Girls, Hot Chicks.
Not wrong. I'm not doing it. Whatever's wrong.
It's funny, but it's just like what we're doing. It's like weird.
So my kids were dumb. So I put like 70s.
Oh, I thought you covered that originally. And then I realized it's on text. Okay, so this is two tails.
Oh, is it 4? Yeah. So you failed that, yes. So you failed to reject
What's the best thing to know about sigma is this. So we're going to assume it's that.
Oh, I got it.
No.
Everybody picked different data, so some of you guys are going to fail, some of you guys are going to reject.
Yeah, I'm so curious. So I've gotten everything pretty like solid. But what I'm curious is like, when are we using? I know you said it. You're gonna kill me. Okay. I was gonna put them in too. But so I get mean, and then I'm getting a variance, but I'm not using those.
Well, yeah, you are. You could have put that number there because it is a square.
So you didn't reject it.
Oh, that was the same time. Well, what about the mean? What am I using the mean for?
For nothing. I just wanted to pick it up on the way because I'm going to ask. I'm going to tell you what the actual mean is and get a feel for how far off.
Oh, it was for this. Okay.
Yeah, the mean is not a part of the test, so it doesn't come into play. But I still wanted you to calculate it. You could just get it off the screen.
Okay, I was like thinking like maybe I should.
That's just for me.
Wait, what am I doing? I just got lost.
That happens. All right. So I obviously this is not right. This is just my data. I picked some data, and this is what I got. The actual mean of all of it was 76.99, like 77 was the actual mean. So who thinks that they're furthest off from that? Who's got a mean that's really far away from that? Anybody? The actual mean is like 77 almost.
I got 71.
71, that's pretty far.
I got 75.
72, anybody less than 71? Who's got, yeah, what you got? How can the average... Are you talking about standard deviation?
What did you get?
Please tell me you're talking about standard deviation.
He said 41. Hold on.
79.
Okay, good. And we got a big one in the 80s? A big mean? Nobody got a big mean in the 80s? All right. And the actual standard deviation was 13.374, so that's why I made the test the way it is, because that's the real standard deviation.
For all of them? Regardless?
For all of this, for all these numbers, that's what it is. So that is sigma. That is the real sigma. So notice that's what I made the claim. I made the claim that it is that. So if you rejected that claim, you didn't make a mistake, because you normally don't have somebody like me saying, well, I know what it is. And then you're like, well, why the hell do we do a test? So if you rejected it, that's real life. Sometimes you reject, you make a type what error? A type 1. Good. You had a 50-50 chance. A type 1 error. I like it. All right, so it's fine. So how many of you guys, anybody get to the point, did you reject it? Anybody reject? I love it.
Failed.
Failed.
Rejected. Did anybody reject it? Okay, 1, 2, 3, 4, 5? And somebody's still finishing up? Okay.
I'm not
That's all right. These things happen. 5, 2, 4, 6, 8, 10, 12.
Jeff, how do we write?
6. 5 divided by 36.
7.138.
Oh, 7 point something?
Yeah. 13%. What was alpha? 10%. All right. Please. Guys, I know there's a little group over there still working. What's the chances that anybody would reject the null when in reality, well, all right, this is not quite working the way I wanted to, but so 13% of you guys rejected the null, right? Which is fine, which is good. I wouldn't want it to be a very big number for the rejection because the actual answer is you should have failed to reject. Not meaning if you didn't, you did something wrong. You guys understand? It just means that
Different number.
in this case, I know what the real answer is. In statistics, you normally don't know what the real answer is, so you can make errors. Who knows? So based on the sample you picked, it could show evidence that it is wrong when actually it wasn't. So let's make sure. Did everybody get that? What were these guys here? What'd you get for the big cut?
43.773.
43.773?
Yeah.
Yes?
Yes.
And 18.1.
493.
18.493? Yeah, I like it. So if chi-squared is less than
18.493.
or greater than,
43.773.
then we can reject the host for that. So what is your hope?
Sigma equals 13.374.
Yeah, sigma equal to 13.374. And the high,
Sigma
not equal to
13.374.
and then this is going to be different for everybody. Yes, sir.
For the was it a little bit higher? It was what you said. Chi-square big was 18, and then chi-square small was 43.
No.
No.
This is
Oh,
I didn't fill those in.
Sorry,
I just put them right on the chart.
I was being dyslexic.
That's right. Now everybody's got a different chi-square based on the sample you picked. For me, it would be 31 times 12.312 squared divided by, oh, where'd it go? Oh yeah, 13.374 squared, right? So that's my standard deviation. Or you can put the variance number there, right? So just don't square it twice, right? If you square it to get the variance and square it again, oh shit, there's no sigma fourth power test, right? Let you know about.
So we use the original.
The original mean for,
In the problem.
well, that was just for me. I mean, that was just because we can get that. It's a good thing to know. Are you asking where we use that?
13.37. Oh,
That's from the clay, yeah. Okay. That was mine. That was mine. I did this problem, so I'm going to show you what I got. The only thing that's going to be different for you guys, for your chi-square, is going to be this number right there. Right? Anybody else get 12.312? For there's S? That would freak me the hell out.
Me and her got the same one. We got the same one.
And you did it independently?
Yeah, we have different numbers.
Oh, different samples, but you get the same S?
Yeah.
Usually.
No, we got the same.
Usually.
The X squared thing.
Oh, you're saying, so then
So
your
we have
S's
all
must be the same.
No.
I think they're, like the back numbers are like slightly different, but we rounded them up to like
Okay, there you go.
three.
There you go. Okay. Okay.
Still, yeah.
So for me, my chi-squared would be, I haven't even seen what I'm doing. 31 times 12.312 squared divided by 13.374 squared. So my chi-squared would have been 26.272. That would be mine,
Jeff?
and I would fall in there. I would fail to reject.
Would we say, like, because you didn't really give us, like, a scenario, so would we say we have failed, like, for me, we have failed to reject the claim that sigma is equal to 13.274?
Yes, exactly. Yeah,
we have failed to say that
the
it's
story
okay.
behind it, like the grades or like something like that.
Did I say that? It is grades. I told you that.
Yeah, but like, do you want us like much stuff like put the grades into the conclusion or no?
So we have failed to reject the claim that the standard deviation of final grades for students.
Got it.
Yeah. Cool.
Oh, that's what I was thinking.
I like it.
Wait, where did you? I know I put support.
You pull it down. Keep it going.
Well, this is mine.
Yeah.
This is all my data.
It's not good. Oh, you
Oh.
want to answer?
But this is my data. It
Oh, I
should be
know.
the same as yours. Okay. All right.
Cool.
I like it. All right, so let's do this. Let's do one hypothesis test all the way out, because this wasn't really all the steps. And then we'll head out. All right, next time we'll get back into the rest of chapter 11.
Are we having quiz next week?
Could be. Let me think.
We only have Tuesday though.
Yeah, we only have Tuesday next week.
Quiz now.
Yeah, because the
We should do it Thursday.
if I was you as a student, I would want more grades.
Yeah.
I don't know if you realize. Yeah. Yeah, I haven't given a quiz on hypothesis tests yet. Have I?
Yes, you have.
Yeah.
Remember, you have like that one big problem and got a small box.
Well, there you go.
2 parts.
Yeah.
Do us another-
Did you
Oh,
go on
yeah.
chapter 12?
Well, we got the correlation problem.
Remember, I just
That's
wanted
right.
to on the calculator.
I love you guys. What I was planning on doing.
Quiz is on a hypothesis test. Is this a hypothesis test? Then no, you shouldn't.
Oh, yeah, that's right.
My friend, I think yep.
So mine has 34, 136. That's what we have failed.
I mean, what do you mean? I'm positive.
All right, guys. So I considered it, and I think I like the idea. So on Tuesday, we'll have a short little quiz on correlation regression. You with me? So I want you to get used to showing me your calculator, showing me what's the data. I'm not going to give you a ton of data. It's going to be a short little thing, right?
Wait, are you talking about chapter 12?
Yeah.
Yeah, that's good.
Okay. All right, so let's do one more. That's funny. I'll just take this one. Yeah, I like it. I like it. So here's an example. We'll take this one right out of the book. So at a post office, waiting times at the post office. Yeah, would you guys say that I'm a pretty patient teacher?
Yes.
You don't want to see me in the post. I use up all my patience in the classroom. I'm in the post office, I'm like, oh, come on. I'm a little freaking kid. Sometimes I get close to using up all my patience in the classroom. Oh. So the post office, they get... Let me see, I'm sorry. I got to rearrange their thing. Okay. They're going to test to see if a single line, they're going to use a single line, shortens, causes lower variance in waiting times. stop there for a second.
So it kind of makes sense. You want to make a test about a mean. Maybe you want to see if I do this, does it cause a higher test grade for students? And that's important. I want to see if it does. If it doesn't, then screw it. I'm going to try something else. But also, sometimes you want to shorten the variability. So if I was given a test and my standard deviations on the test were coming out to be 20-something, I'd be like, holy shit, I got to do something to make the standard deviations shorter. Why are some people totally not getting it and some people totally getting it? I got to figure out what that is. You guys kind of understand? So it makes sense for the post office. They want to have everybody have tighter times, and somebody's not like real quick, and somebody else is like waiting days to get out of there. Let's go. Or just maybe it feels like it to me. All right, sorry. So the normal waiting time, the normal sigma is 7.2. That's the way it is now, and they're going to change it. So they change it, and they take a sample of 25 customers with the new stuff, and they find S to be 3.5. That sounds promising. But it's a relatively smaller sample size, right? So we don't know if that's enough evidence yet. Then I said it and I didn't write it. Hey, there it is. 25. Okay. So let's try this. Oh, alpha is 0.05. Okay, so 1. Say it again. You good?
Yeah.
So step 1, what's the claim? Careful. So this is normally what sigma is. So, but the claim is not this. What's the claim?
Lower, less than?
Causes lower variance. So the claim is sigma is less than 7.2 now. Right? This is what it was before we made the change. We make a change. We make a single line instead of several lines to see what happens. And this is what happened. We got that standard deviation instead. Sounds like it should be the other way around, but oh, we'll just go with what they got. So this is what it was before. We made a change. We observed this. What do we think this change is going to happen to this? We think it's going to make it go less than what it used to be. All right, so normally it's 7.2. We think it's going to be less than 7.2 now that we made this change. Which one is that, of course? High. The high. And of course, the ho is the opposite of that, so it's going to be a, how many tail?
1.
1 tail. Hold on. Okay, cool. Oh, that's all the room I got. Second step. I'm going to just have to tell you. It's normal. Right, but they didn't say, and they just do it anyway. So yet another note for the author. So it's normal these truths. So we can use chi-squared. Check.
Yeah, 25 is less than 30.
Yes, because I wrote that.
Oh.
So let me just say this. We're getting used to all these processes that you can use to analyze data. In the real world, this is a huge concern. Is it normal enough? Is it normal enough? Can I do this? Because there are other things you can do that get a little bit weird that would be in a Stats 2 class for people where you say, okay, if it isn't normal, how do we adjust this? Or what do we have to do? You guys kind of with me? If it is normal, everything is much easier. Right? So right now we're just getting used to these processes, so we're going to assume almost everything is normal so we can actually do it. Because what would you do if it wasn't normal? Entirely different stuff in some cases. Third step. Rejection region. One tail test. Where's the tail going to be?
2, right? 2 above.
Yeah, one less than, right? Less than correct, so it's going to be left. Sure. Alpha is 0.05. One tail test. Degrees of freedom is 24. How does it come out? So be careful. 0.05, what am I actually looking at? That's there, so what's...
0.95.
Yeah. 0.95. 0.95, stop at 24. Good, 13.848. The gas. So very quickly, if chi-square is less than 13.848. Rejected, no, just put that. I guess I should. Reject. No. Support. Aye. I have 3 P's in support, but oh well. Support my decision to do that. Support. Alright, so now that we've set up what far enough away is, we'll go and see how far away we got. So it's kind of nice, let it be nice that the steps are the same. It's just that the internal workings of each step is a little different. So chi-squared in general is n minus 1 s squared over sigma squared. So now it's going to be 24 times 3.5 squared divided by 7.2 squared. I like it. Sigma comes from the claim just like mu came from the claim. You can't see that at all, can you? There it is. And whatever the hell you do there. Six.
You're getting 5.67?
Yeah, close, right?
Yeah.
Give me a little leeway. 5.6. 1. And what's important about that? Where did it fall?
In your rejection.
We made it!
Or the marsh.
5.671. We made it.
Looks like
We made it. So then we can say what?
yes.
Reject the support the high.
So we have to find sufficient evidence to support.
What?
So we have to find sufficient evidence to support.
Yeah, okay. I like this. So we're going to use this language because the claim was
About the high.
less this was high. So we want to use this language. We have found
Sufficient evidence.
sufficient evidence to support the claim that the new method reduces variability in waiting times for customers. All right, so they have a more similar experience. Does that make sense? So you don't have somebody waiting a million years and so on. So sort of like a microwave company might want to reduce the variance in hot spots in their microwave oven so that you get a more even cook. You see what I'm saying? So that there are definitely places you want to control for what the standardization is, or try to change it, try to see what can change it. All right, I don't know why I was rushing that much. I just felt like it was done, but we're good. That's